Hey guys, this video is going to go over dividing radicals and then something called rationalizing the denominator of a fraction that involves radicals. All right, so first thing I'm going to show you are the dividing radicals rules. It's kind of like the multiplying one. So basically, if you have a radical, something like this, maybe 16 over 25, you can split it up so that it says the square root of 16 divided by the square root of 25. Okay. It also says, if I kind of worked backwards, that I could do, if I had the square root of 16 over the square root of 25, I could rewrite that as the square root of 16 over 25. So you can kind of go either way. Okay, so here would be a time when you would maybe use this. So I have the square root of 20 over the square root of 2. Now, neither of those answers is very nice. So what I can do is I can actually rewrite this as the square root of 20 divided by 2. Okay, now let's look what happens. 20 divided by 2 is actually the square root of 10. Okay, now I really can't simplify it any more than that, but that would be my final answer because I cannot divide that by any perfect squares. Okay, let's take a look at another one and where it will kind of be helpful. So this one, the square root of 6 divided by the square root of 3, you can actually rewrite as the square root of 6 divided by 3. And this is kind of nice because 6 divided by 3 is 2. So now I just have the square root of 2. So this looks a lot simpler than this original one did. Okay, so the next one, we have 6 square root 10 divided by 8 square root 2. So on this one, you can actually kind of split it up into two fractions. I'm going to pull this out, 6 over 8 times the square root of 10 over the square root of 2. And then this part I'm going to rewrite as, so I'll still have my 6 over 8, and then the square root of 10 over 2. And then 10 divided by 2 is square root of 5. So I actually have 5. And then 6/8, I'm going to try to simplify that. I'm going to divide it down. 6 divided by 8 is, or 6 divided by 2 is 3. 8 divided by 2 is 4. So this is the same as 3/4 times the square root of 5. Again, that answer looks a lot simpler than the one that I started with. Okay, let's try a couple here. So I have the square root of 12 divided by the square root of 3. If I use my little rule, I can rewrite that as the square root of 12 divided by 3, which is nice because 12 divided by 3 is 4, and then the square root of 4 is 2. Okay, so the next one. I'm going to rewrite this as 2 times the square root of, I'm going to put those together, 20 over 5. It really works nice when the denominator can fit into the numerator. So 20 divided by 5 is 4, so I end up with 2 times the square root of 4, and then the square root of 2, or of 4 is 2, so I end up with 2 times 2, which my final answer would give me 4. All right, let's go ahead and try this one. So if I was doing this one, I would start by doing the 4 divided by 2, which ends up being 2, and then I will kind of rewrite this part as one fraction here, square root of 30 over 3, and then 30 divided by 3 is 10, so I end up with 2 times the square root of 10. I cannot break that down any further because there's no perfect squares that go into 10. Okay, this one, a lot of you might go directly to just rewriting it like this. Now, if you do that, 15 over 4, that's a decimal, and it's not a nice decimal. If you try to do the square root of it, it won't work out nice. So hopefully you kind of noticed that 4 is actually a perfect square. If that happens to be the case, actually work it out. The square root of 4 is 2, and then I still have 15. So really, my final answer is the square root of 15 over 2. Or I could even pull out the fraction and say that's 1/2 times the square root of 15. So those both would be acceptable. Okay, so something that I haven't mentioned yet is when you are working with radicals and you have fractions, to be in simplest form, the denominator cannot be irrational. Now, you guys might need a quick review on what an irrational number is. So irrational numbers are numbers you can't write as a fraction. So basically, it'd be like pi is irrational because that's a number that never ends and it never repeats. So if I gave you another random decimal like 1, 2, 4, 7, 6, 3, 1, 7, 8, and it just kind of keeps going and there's no pattern and it never ends, that's irrational. Another irrational number would be like the square root of 3. It's not, if you type that in on your calculator, it's a decimal that never ends and never repeats. Okay, so when you're working with radicals, you cannot have a denominator that is irrational. So we're going to do something called rationalizing the denominator. Basically, that means we're going to make it so the bottom is okay. All right, so let's look at this first example. So if you guys notice on the bottom of this fraction, I have the square root of 3. That is not a rational number, so I cannot have that on the bottom. If you had tried to rewrite it as the square root of 10 over 3, it would still have an irrational number. It would still be an irrational number, so we still want to try to get rid of it. So here's how this can work. So what you can do is you can actually times this fraction by a number that will still keep it the same. It won't change the value. So think about when I'm multiplying numbers. If I wanted to keep 5 times something and I want it to still equal 5, what number has to be this question mark? Well, it'd have to be a 1. 5 times 1 is still 5. So whatever I multiply by right here, this needs to be equal to 1. So I will show you what you can do. So you can actually multiply this fraction by the square root of 3 over the square root of 3. So that basically is just a 1, right? Because square root of 3 divided by square root of 3 is 1. So I'm not changing the value of this original problem. Now let's look what happens when I do this. So on the bottom, I end up with the square root of 3 times the square root of 3. And on the top, I end up with the square root of 10 times the square root of 3. Okay, so now let's see, why is that actually helpful? Well, the square root of 3 times the square root of 3, that's the same as writing the square root of 9. And on the top, the square root of 10 times the square root of 3 is the same as writing the square root of 30. Okay, so now I just have one more step. The square root of 9 actually works out to be nice, which is 3. And then I still have the square root of 30 on the top. The square root of 30, there are no perfect squares that go into that. So this would be my final answer. And now this answer is okay because on the bottom of my fraction, I have 3, which is a rational number. So again, that's okay. All right, let's take a look at this next one. Now, square root of 1/3 is not a nice number, but let's go ahead and actually split that up. We know we can split that up into the square root of 1 over the square root of 3. Okay. Now, if you look at the bottom, the square root of 3 is not a rational number, so I want to get rid of this on the bottom. So to do that, I can actually multiply this entire fraction by the square root of 3 over the square root of 3. Now, again, this is what I just wrote here. This is really equal to 1, remember, because square root of 3 divided by square root of 3 is really 1. So I'm not changing my fraction at all. Now, let's see what happens. Okay, so on the top, square root of 1 times the square root of 3, that would end up being the square root of 3. On the bottom, square root of 3 times the square root of 3. 3 times 3 is 9. Okay, now let's see what happens. Well, the square root of 9 on the bottom is 3. And then on the top, I just have square root of 3. So my final answer is square root of 3 over 3. Now, another way to write that is you could pull out this fraction and rewrite that as 1/3 times the square root of 3. That would also work. Okay, let's look at this next one. So I want to simplify this radical expression. And remember, you cannot have an irrational number on the bottom. So you can't have basically a square root on the bottom. So if I want to get rid of the square root of 2, I can actually just multiply by the square root of 2. Now, again, I can't just multiply the bottom by it. I also need to do the top because this right here is really a 1, right? So I'm really just multiplying by 1. So let's see what happens. Okay, on the top, if I do 1 times the square root of 2, I end up with the square root of 2. On the bottom, if I do square root of 2 times the square root of 2, I end up with the square root of 4. And then I can just simplify this one more time. The square root of 4 is 2. And then on the top, I still have square root of 2. All right, I cannot break down the square root of 2 anymore. So square root of 2 over 2 is my final answer. Okay, let's look at the next one. On the bottom, I have, well, first thing I would always suggest you guys check is, does 12 go into 27? It does not. Very nice. So I just want to get rid of that bottom of the fraction. So I am going to multiply by the square root of 12 over the square root of 12. Remember, that's just like multiplying by 1. Okay, so on the bottom, if I do the square root of 12 times the square root of 12, that's really the square root of 144, which equals 12. Hopefully you start realizing that when you multiply the same thing by the same thing, square roots, it equals that number, the radicand on the inside. Okay, on the top, square root of 27 times the square root of 12 actually equals 324. Okay, so now the bottom of my fraction is nice. That's a rational number. But I need to see if I can simplify the square root of 324. Now, before I even try to break it down, I'm actually just going to type in square root of 324, see if it's nice. It does happen to be nice, so always check that to start with. The square root of 324 is actually 18, so I end up with 18 over 12, and then I can actually divide that out. So 18 twelfths, that's the same as 3 halves, or 1 1/2. Okay, and that is definitely simplified. All right, why don't you pause the video and you guys try to simplify these two. When you're ready to see the answers, push play. Okay, I'm just going to quickly walk you through these two. So I times by square root of 10 over square root of 10. I ended up with this, and then you have to be careful. You need to simplify this. 8/10, that's the same as 4/5. So just make sure you simplify it. Square root of 10, I cannot break it down. Okay, this one had a lot more steps in it, the second one. So I multiplied by square root of 200 over square root of 200. Okay, ended up with 200 on the bottom, 4 square root of 200 on the top. I divided both of these by 4, so I had 1 over 50, okay, and then square root of 200. Now, square root of 200, I knew I could split that up. I split it up into 100 times 2. And then the square root of 100 was 10, okay, so 10 times 1 gave me 10 here, over 50, and then I still had square root of 2, and then 10/50ths, I need to simplify that to 1 over 5, and then I still had my square root of 2, so that's my final answer. Okay, let's do another one together just to make sure you guys have this. So I'm going to do this bottom one. So first thing I check for is 2 and 15. If I divide that out, not nice. So I need to get rid of the bottom of the fraction. So that irrational part. So I'm going to multiply by the square root of 15 over the square root of 15. Okay, so let's see what happens. So on the top, I get 3, and then 2 times 15 is 30. So square root of 30. Okay, on the bottom, the square root of 15 times the square root of 15 is going to end up giving me 15. And then there's still that 2 there, so 2 times 15. Okay, so my next step is I'm just going to simplify a little bit. I end up with 3 over square root of 30. And on the bottom, 2 times 15 is 30. Okay, now you always need to simplify. 3 goes into 3 once. 3 goes into 30 10 times. So I end up with, on the top, I just have square root of 30. On the bottom, I have 10. Now, square root of 30, there are no perfect squares that go into that, so that is all the way simplified. So my final answer is square root of 30 over 10. All right, I have 3 more for you to try. If you're feeling good on these, you can move on to the practice. If not, you can watch me go through. I'll probably just do the bottom one, but why don't you pause and try these, and then you can check your work, and I will go through one of them with you. All right, so here are your answers on these 3. You can go ahead and check those out. Just remember, I'm kind of not showing one step. Square root of 3 times the square root of 3 is really the square root of 9. Okay, I'm just kind of skipping ahead and writing that answer is 3. Same thing here, I split it up. Okay, and then I multiply by square root of 2 over square root of 2. I ended up with 2 on the bottom and then square root of 2 on the top. And then the last one, just make sure you're careful here. Square root of 2 times square root of 2 is square root of 4. And then that equals 2. And then don't forget, you still have that times 3. 3 times 2 is 6. And then I have square root of 22 on the top, which no perfect squares go into square root of 22. So I am done. All right, if you have any questions, please talk to your teacher and ask them to go through more if you don't understand this. Thanks, and have a great day.